What's up mga Chimex? Sir Jello here. Now, last time we've talked about the electron configuration, or it simply means na the distribution of the electron of a particular element. And hopefully you've learned how to write the electron configuration itself. For this session, we are going to talk about a simpler way on writing the distribution of the electron, or a shorter way in writing the electron configuration of a certain element. Plus, we'll get to learn other information because of that shorter notation. So for this moment, we are going to talk about the noble gas. Alright, it's not working. And thank you, Sir Sid, by the way, for the whiteboard markers. We're going to talk about the noble gas notation, or the noble gas. Some books would call it noble gas configuration. Some would say noble gas notation. Anyways, it's a notation, or it's a configuration using the noble gas. Now, how do we do it? Alright, let's get a refresher course on how do we write the full unabbreviated electron configuration. Let me use another marker here. Hopefully this blue one works. So last time, I've talked about the Aufbau principle, or the electron distribution mnemonics. Some of you might have seen it in the side. Often it's on the corner, either upper left, upper right, or bottom left or bottom right corner of your periodic table of elements. In here, it's on the bottom right corner, the Aufbau principle. Now, last time, if you can remember, I did not tell you to memorize this one, but rather, I told you how to write it, and where did it came from. So, if you can remember, so without even memorizing the arrows, you can actually, or memorizing the sequence, you can actually create your own. But if you can remember it, I told you that every atom has three main parts: the main energy level, or the shell, the sub-energy level, or the subshell, and then the orbitals, which contains the electrons. And each orbitals has different number of electrons in them, a specific number of electrons in them. So, to write it off, we'll start with the first energy level. Since for every energy level, there is a corresponding sub-energy level, the first energy level would only contain one sub-energy level, or one subshell. Therefore, first energy level would have only one subshell, the S. We only have SPDF subshells. First, we label the numbers, and we have the second shell containing two subshells, the S and P. So that's the P on the second shell, or the P subshell, or the second shell. That's why we have it. And then the third subshell would, of course, the third shell rather, or third energy level, would contain three subshell, or three sub-energy level. You see, I've been using different terms so that you'll not be confused, and hopefully you are not being confused. Again, these numbers are your main energy level. Some books will call them shells. These letters, S, P, D, F, are your subshells. Some books will call them sub-energy levels. Basta may sub-saban. Yan. And, of course, third energy level will have its third subshell, the D. And so on and so forth, for S, for P, for D, then we'll have the 4F. On the fifth shell, we'll have 5S, 5P, 5D. And we said we only have until F, so wala nang 5G. And then we have 6. Yan, I lost some space. 6D, even, and 7S, 7P. Alright. And pwede mo pa rin tong dagdagan ng 6F, and you'll realize it will be useless. So sometimes I don't write it. But for convenience, or rather for formality, I'll write it. Though again, there's no element that would exceed or will go beyond these shells because the last element is oganeson ending in 7p6. Later on, I'll realize why. And then, I've also told you that the arrow should not go from left to right, bottom, then left to right once again because of the shielding of effect of electrons, no, of the S shell being smaller than the D shell, no, or containing less electron than the D shell, so they overlap. That's why we start with 3p and then followed by 4s, then 4d. If you can see here, no, my camera is very far. So here, let me focus the camera. Right. So in your mnemonics here, 3p, 4s muna bago mag 3d. So that's the reason behind it. So we'll be using this one. So let's just recall, no, or let's try to write some electron configuration of elements, no, just to recall what we have learned in the last video. Again, sorry for the instability of my video. I am currently using my left hand to, left and right hand. One for capturing vid and one for using the whiteboard and the marker. Well, anyways, let's try silicon, one of the interesting elements. So what we need to do is to identify the atomic number. Silicon is atomic number 14. Therefore, since it's 14, so silicon 14 will have protons, 14 protons. Hopefully you can see the marker. And then 14 electrons as well because it's a neutral atom, it's an element. Therefore, I need to distribute these 14 electrons into their respective energy levels and their respective shells. So, looking back on my mnemonics, the Upbow principle, I need to fill out first the first energy level and the first subshell. We followed by the second energy level and the S subshell, second energy level and the P subshell, and so on and so forth. We learned already here that the S subshell will contain one orbital which can hold 2 electrons. P orbital contains 3. A P subshell contains 3 orbital. D contains 5 and F contains 14. No? If you're still confused with that, you can try to watch the video once again. So let's start by using 1s. So that would be 1s. Well, let me just place it on the bottom of this one so that yan and one capture. So 1s, I'll write 2 electrons here for my 1s, 1s2, and then followed by 2s, that would be 2s2, and then 2p6, and then 3s2, and let's count so that will not exceed 2, 2, 10, 12. I need 2 more, so that would be my 3p2. Alright, this would be the electron configuration of my silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Again, I am following the mnemonics or the Aufbau principle. Now, well, this is a bit easy if we are talking about the elements on the first 2 shells or first 3 shells probably. But what about the elements on the 7th, like the UUO? No, this is not updated. The oganeson. You have to distribute the 118 elements. Can you do that? Yes, of course you can. No, but it would be taxing and it would be time consuming. It would waste a lot of paper, etc., etc. So scientists realize that they can make things easier. The chemists, or kahit ano namang scientists, they are fond of making things easier. That's the job of science, right? Therefore, they realized something. The noble gas can be used. So, paano natin gagamitin si noble gas? And bakit si noble gas ang ginamit? So, first things first, in the previous video, I've told you that the first two groups are our S group, meaning S subshells. All in group 1 are the elements ending in S1. No? All the elements in group 2 are ending in S2, including the helium. And then here we have the D group. So this is D1 until D10. The F group, that's why the lanthanide and actinide series are 14. So that's 1 to 14. That's F1, F2 until F14. And we have here from boron until the noble gas, the P group, no? The P shell. So this is your P1, P2, check natin. Silicon ends in P2, therefore it's in this group. No, it's in the 4th group, or 4A, or 14th group. And then we have the noble gas ending in P6. So amazing, no? All these noble gases except helium, because it has only 2 electrons, which makes it end in 1s2. Neon until oganesson ends in P6, no? A full electron in the p orbital. And when you include the s orbital on their shell, it makes the noble gas octet, no? Full octet, meaning 8 valence electron, no? And because of that, they said that we can use this noble gas to make our electron configuration shorter by replacing the P6 configuration with their corresponding noble gas. So what do I mean by that? So let's check here. 2p6 is a noble gas kasi p6 siya in the second period because the shell is 2. So that would be 2 and neon. So to replace this one, I need, let me use a green one, no, for better visual. To simply replace this 2p6 inside the bracket with the noble gas. So that would be neon. And then copy the remaining electron configuration. That would be 3s2, 3p2. There you have it, a shorter way to write the configuration of silicon. So why is it interesting aside from it makes the configuration or the list shorter? It's very interesting because at this point, the noble gas, it is the noble gas configuration. It's a full octet, meaning all the remaining electrons after the noble gas are what we call the valence electron. And by this, we'll know that silicon will have 4 valence electron. 4 valence electrons. Hopefully that makes sense. Now, let's give another example. And we'll use the noble gas configuration. So first, let's try what element should we use now. Let's try magnesium or calcium. Calcium para may iba naman na noble gas. So calcium, the atomic number is 20. Therefore, calcium will have 20 protons, no? It's a neutral atom, and then 20 electrons. So I have to distribute the 20 electrons, now using again my Aufbau principle. So my mnemonics. So I'll be writing 1s2, 2s2. You can have a copy, pero later on memorize mo din ito, 2p6, 3s2, and then 3p6. We check, we have 2, 4, 10, 18, we still have 2 more. So here, again, be careful with my heart. Char. 3p could end, could mislead you into going to 3d. But we have learned that the arrow goes like this. Right? So after 3p, you need to go to 4s. So 3p, what will complete the calcium configuration would be 4s2. Right? This is the long configuration. Now, to apply what we have learned on how to write the noble gas notation, we'll be looking for the biggest or the largest P6 shell, no? We have two shells here with P6 as their subshell or complete octet, if you might call it. 2 P6 and 3 P6. Now we choose the bigger one. So we use this one, 3 P6. And again, you need to memorize this portion now. What noble gas notation is in period 3. So period 3 would be argon. So ito lang naman yung i-memorize nyon. Helium, neon, argon, krypton, xenon, radon, and oganesson. Well, anyways, oganesson cannot be used. So you only have 7. Bakit? Because it's the end, or it's the last element. So no elements to configure on the latter part or to add on the latter part. So here, 3p6 is our argon. Meaning, if you'll notice, a while ago we used silicon and neon was the noble gas used. Here we use calcium and the noble gas used is argon. Meaning, for every element, the noble gas configuration being used is the preceding element. Meaning, the noble gas element before them. This would be 3p6. I simply need to enclose it in a bracket. So, full bracket. And then, I'll place the chemical symbol of the element argon. And then, I simply copy the remaining electron configuration. Therefore, this will be the noble gas notation of my calcium. So, this is equal to my calcium. Interestingly, as I was saying a while ago, aside from the fact that it lessened, it makes our long electron configuration shorter, it tells us the valence electron of a specific element. So here we'll know that the calcium will have 2 valence electron. Meaning, if you can still remember our definition of valence electron, it's the electron on its outermost shell. So the outermost shell of calcium is in the 4th shell. Meaning, kung idodrawing mo siya, 1, 2, 3, 4th circle with 2 electrons here. No, if we're using the planetary model. So, easily, I can simply say that if I make my calcium lose 2 electrons, the configuration will be equal now to argon. No? By removing this, diba? And ano na to? This is now our ionization, right? Creation of cation, preparing them for a compound. Making, diba? Science is very interesting. Let's have our last example. Now, hopefully, you're getting it. Pahirapan natin ang ating sarili ng konti. No? Doon tayo sa medyo mahaba. Dito tayo sa tin. Right? Alright? Ay, hindi. Medyo maikli pa yan. Let's go with sige, tin na lang, 50. Ayoko din pahirapan masyado ang sarili ko. Because I still have to write the full electron configuration. So, tin, that's Sn, 50. Protons would be 50. Electrons will be 50. So, following the Aufbau principle, again, that's why I keep on writing them over and over again. So that, it's another way of not memorizing, but actually understanding it. Sabi nga, there's an adage saying na if you study to remember, you will forget. But if you study to understand, you will remember. So if you know where it all came from, you'll realize the beauty of chemistry. So yan, 1s2, 2s2, 2p6, 3s2, 3p6. Dito na tayo, magiging careful because the trick of the shielding effect goes here. We'll have 4s2 to be followed by, sige, lagyan natin ng arrow, 3d10. 5 orbitals can contain 10 electrons to be followed by 4p6 and then 5s2. Check muna natin before we continue with 4d. So, 10, 20, 30, 36, 38. We need 12. So we go now to, our last was 5s2. We go to 4d10. 4d10 and then 5p. We only need 2. So 5p2. Alright. Sige, check natin if it's correct. Mukhang there's something wrong with my equation. It's correct. It's correct. 5p2. Alright. So now, I'll be looking at the biggest P6. So I have 2p6, 3p6, 4p6, 5p, but it's not 6. It's not a complete octet. So I'll be using the 4p. The 4p of Ateneo. 4p6. Sorry. So 4p6, and that would be the noble gas on the fourth period. Fourth period noble gas. Ding, 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 ding. That would be krypton. Alright? Krypton. So, I'll be using krypton enclosed in a bracket. Don't forget the bracket in writing. And then copy the 5s2 for the 10 and 5p2. Now, some periodic table of elements would rather use 4d10. Now, 4d10 as first than the 5s2 and the 5p2. Merong ganyang format. Some periodic table. But following the AFBAW principle and the rule, this is the answer on a noble gas notation. And by the way, you can actually see the shorter configuration on a big modern periodic table of elements. So let's check here. Tin, where are you? Yan, here, tin. They have KR, 4D10, 5S, I joke, what pala? 4D10, 5S2, 5P2. Just like our answer. Kanina, we have silicon. That's your 3S2, 3P2. Neon. Again, it's not a parenthesis. Don't trust your periodic table of elements. It's a bracket. And then the calcium, that's AR 4S2. Alright? There you have it. Now, hopefully, you've learned the noble gas configuration or the noble gas notation. I'll be uploading an activity for the electron configuration and noble gas notation. So in case you're missing the senior high school, this is my classroom last year with the wonderful SE26. So, yan, hopefully, I'll be seeing you in real person, in actual faces. But for the meantime, let's think of what we can do and accept the things that we cannot change. Thank you so much. This has been Sir Jello. Peace out.